Good morning. My name is Mike Boyce. I am the Safety Administrator for the Upper Northwest KMA. I am here to introduce you to John Williams and the safety team from Benton PUD. First, I want to take a minute to talk to you about your FVD, provided by Charter to keep you safe from any source that may be in your work area. This small orange tool could save your life. It is used to help you detect power. It only takes a few moments to use your FVD to detect a power source that could harm you. But please remember, if you choose not to use your FVD or get in a hurry and not use it, we could be contacting your family for a serious injury or death that could be prevented with this very important safety tool. Charter's #1 goal is to get you home safely each and every day, and no job is too important to bypass safety. Safety is first, last, and always with Charter. I want to welcome the Benton PUD Power Safety Team for today's training. They will take us through the proper safety processes so all of us at Charter as employees can work around power each and every day safely. It's all yours, John.
Well, thank you, Mike, for giving us the opportunity to present our high voltage safety demonstration for your gentlemen. We think it's extremely important. Electrical safety is one of our that's one of the things we live with. Safety, no matter what, is our top priority. Now, right off the bat, I'd like to do a real quick intro. I've got Shane Brown here on my left, far left, Joe Garner, and myself, I'm John Williams. We are journeyman linemen with Benton PUD here in Kennewick. Now, you know, most of us take electricity for granted. I know I do. I'm as bad as anybody. Day like today where it's nice and cold, go home today, I expect my house to be nice and warm. Open the fridge, I grab a cold Pepsi, I hit my remote, and I expect my TV to come on. You know, I don't go home at night going, boy, I hope PUD's got the power going today. It's just, we take it for granted that it's there. And basically that is what our job is, to ensure that you have safe and reliable power 24/7. Now, this trailer is a representation of the top 10 foot, basically, of our 7200 distribution line. And right now it's being backfed by a pad-mounted transformer. Now, the transformers, they do just what they're called. They transform the power. Normally, you've got a 7200 volts coming out on the line, comes down into the top of the transformer, and through differences of windings, through induction, you end up with 120, 240 volts that goes out to your home. Well, we've got it the other direction. We've got it fed into the side of the transformer, but just regular service voltage, and it kicks it up to 7200 that we're using here on our demonstration. So, one other thing is, you know, we go on a lot of mutual aid on storms. We go across the mountains, and a good percentage of the people, they have generators. Unfortunately, they're not all hooked up correctly. And so we always have to be careful and aware, because if a person has a generator hooked up to their home incorrectly, they can be backfeeding the transformer out there, energizing the line that we're working on. So that kind of thing, that happens also. Now the trailer, you see we got the nice pretty little barricades, and that's a safety precaution. When we're drawing the arcs, the potential is that this trailer is at 7200 volts that we're standing on. So that's why it's up off the ground, because say for instance, if I was standing on the ground with one leg and standing on the trailer and he drew an arc, the potentials, I'd have 7200 volts running through me. And that's kind of like a bird, you know, you get a bird sitting up on a wire, that's kind of what we're doing. You know, there's no circuit. So, okay, well, we'll get with some of our little demonstrations here. Right off the bat, I'll fire up the trailer, and we like to show our little Jacob's ladder. It kind of gets things going. So that's a good way to start. That's the kind of thing that's up there. You know, the thing is, with electricity, you know, those wires, they just kind of sit there. They don't make any noise. They don't glow red that they're hot. But you can see where there's a little gap there. And all it takes, you get within about 3/8 of an inch, you start those arcs. And once you start that arc, you know, get hold of that line and you try to get away, that arc just pulls out with you. You know, it's hard to get rid of it. Now, say for instance, I like using an example, new driver, out driving, having a good time, texting on the phone, runs off the road, hits power line, shears it off, the line hits the ground. And hopefully it'll blow a fuse. Now we do have these doctored up a little bit, so they're not like a shotgun blast, tear your ears up. But we like to do these a couple times because we do not get to play with this very often. But the good thing about it, say for instance, line hits the ground, we start getting calls in. And we know, you know, from the people looking at the map, well, this person's off, this person's off. And then after a little bit, you're looking, well, there's a fuse here. Nobody upstream is calling. So what we do, we go out and we look for one of these hanging down to start with, a lot of residential areas. And it protects our equipment and it protects the customer if something is on the ground, that, you know, it de-energizes everything downstream. Now, I'd like to mention that, you know, at no time do we use live animals on our demonstrations. But we do have Fluffy here. Now, say for instance, old Max, the neighborhood bulldog's chasing poor Fluffy around the house and Fluffy decides to run up one of our poles. Now this can happen, and I will add sound effects to this. Now that's, you know, that's about as close a representation we can get, because actually that's what happens. You get an animal, whether it's a cat, squirrel, hawk, they'll get in between a ground and the phase. And they'll complete a circuit, and then that's usually about the end of it. Now we've got a lot of real nice signs here. You know, we hit fairs, we go to jobs, school, you know, where they're looking for work, job fairs, you know, elementary schools, you name it. And a lot of times, you know, we'd like to make sure that they see the signs. Now the young kids, we show the example of a kite string. Now we want them to know that at no time we want to get them in trouble. We're not trying to make them, you know, give them a bill, but if they do get a kite string in this, up in the power lines, we want them to call. You call 911, have someone call, you know, the PUD. We want to come out, we'll get the kite down, and we leave. You know, we don't want to scare them. We want people to be comfortable with calling us for help. But if they are holding on to that kite string, this can happen. So the main thing, you know, we just don't want the little guys holding on to that string when it goes to phase.
Wow.
Yep. The last time I was out, I got a Barbie kite off the line. I put it back down on the ground where the little girl could get it, and of course they're nowhere to be seen while we're there, but now the hot dog, that's about as close a representation as we can get to the finger. And say for instance, you know, I use that example of a car hit a pole. Now, if a person were to go over there and just try to move that line, not knowing if it's energized or not, if they grab hold of that thing energized, this is a good example. Bad thing about electricity is trying to find a path of least resistance. And we see videos all the time, kind of to shock us into compliance, you know. Someone grabs hold of something, it may not be a tremendous burn, but it depends on how they grab it. You might grab hold of something, electricity goes down through your bloodstream or your nervous system, across your heart, out your foot. And a lot of times it just cooks you from the inside out. And we see guys, you know, the first week they might lose a finger or two, next week part of their arm, and it just keeps going. So, like I say, you don't want to touch anything.
You want me to pass the hot dog around so they can see when it contacts when it didn't? That's
No,
it.
that's all right. Yeah, we could do one more of those. Those are kind of good. Like I say, you see that arc, you got several thousand degrees there. And once you start that arc, like you say, if someone was to grab it, try to get away from it, you can see how that's just going to drag right along. You know, it just stay with you. Now Shane has what he has there is a primary glove. Now we do not actually handle our energized conductor with gloves. We're one of the only states left that doesn't. We use these sticks. It takes a little more practice, a little finesse, but you can kind of visualize if you're up there, something goes wrong, you're right there working on it versus at the end of a stick. And we'd rather be a little bit farther away. Like I say, there you can see there's some protection there. And you know, we've got cover when we're working up in the air, like this orange one. But we'll put those gloves on if we cannot completely cover everything up just for an accidental contact. We'll wear the gloves. But now if a person was just to like come up to that car accident, think they could grab any kind of little rubber gloves, put them on, be safe to move a wire, this is what happened. Not much protection. So like we say, you know, we got another one there. Like I say, we kind of enjoy doing this. We don't get to do this out in the field. The company doesn't like it, so we do it on the trailer here. But like I say, the gloves we have, they're tested at 20,000 volts. The rubber, the leather's on there just to keep from, you know, scratching, cutting the leather, or the rubber, excuse me. But like I say, we always have those. We have, you probably haven't seen us with the secondary gloves. Oh, for like up to 600 volt, we'll be using these to make connections. Now when I was in high school, I went out farm area, changed hand lines, made a little extra money. But there's constantly people killed every year raising equipment and hand lines up into the power lines. And this is an example of what would happen. It was a few years ago, back I think it was in New York, Boy Scout Jamboree. Several of the Scoutmasters were raising up the center pole of the tent, and they started losing control of it, and they kept hold of it, and it laid over into a power line, and it killed all of them. So, now these balloons, I love these balloons. They're metallic, a lot of good overtime with these balloons. Birthday parties, weddings, you name it. You know, they have the, you know, several of the balloons. They cut them loose after it's done, they go floating up, get into our power lines, and they make a mess. And we'll show you kind of what we're talking about. And a lot of times once they start an arc, it doesn't stop. So, all right. Well, the secondaries, you know, we're talking 7,200 volts to ground here. This is the voltage going into the home. Joe's got a 120 volt leg, hot leg here, and he'll throw it to the sink. But what we try to stress is, you know, the young people, blow dryers, curling irons in the bathroom, and this is what they're plugging into. And they're complacent, you know, have no idea. We use electricity all the time. I don't think anybody thinks twice about it. And there's a 240, here's the two hot legs together. So when you're out there, you're going to see a lot of that. You know, you're going to see, I'll kill this trailer real quick. From the transformers, you're going to see the triplex like this going to the houses, the weatherheads. That's exactly what he was slapping together, 240. It doesn't take much for the squirrels to chew through this. If we put it up 10 years down the road, trees grow up, it doesn't take much for a limb rubbing against this to wear it. And it can be within 1/8 of an inch of that neutral, the bare wire. And if little guys are climbing up in the trees, playing around, they grab hold of that. It's not good. And I'd say this is the kind of thing that you're working next to. You know, it usually, you know, just directly below the neutral. Duplex, you probably see a lot of this right below the neutral going from the street lights. There's 120 between the two. Of course, you got the primary. Like I say, our system's 12,470 volts. We call it that. That's phase-to-phase voltage. Then you got the 7,200 to ground from in into the phases. This is 336, we call it. This is like, running up and down Kellogg there. One other wire would be like this number 6. And you kind of wonder, well, the big stuff's going to the house. What's this little stuff doing? But don't let it surprise you, because this can be running for miles. And, you know, the higher the voltage, you know, it's inversely proportional. You know, you get 7,200, the amperage is a little less, and then it kicks it down to the 120 volts, and the amperage shoots up. So, you know, you can run the high voltage down the line, and then, you know, you end up with a bigger wire. You kind of wonder, well, that's so little, how can you carry so much load on it? So, but don't let it fool you. Now our underground primary, this is the older stuff we have in the ground. A lot of it's just direct buried. If you're trenching and digging, you may see some of this. Now this is the newer, it's got a jacket on it. But you can see both of these in, you know, risers, still. And the problem is, see, we try to keep our top of our conduit riser on the primary 9 inches above the neutral. And the secondary risers are usually about 18 inches below the top of it. Now some of you are telling me a story about a squirrel chewing into one of those, and they do. They love chewing on this stuff. You get this triplex underground conductor, it comes up out of that riser, and those little guys like sitting up there and chewing this. And they get those things bare. So if you're up there, anywhere close, just don't keep, you know, get your hands around any of the conductor at all. Because those things at the top of the riser, all 3 legs can be bare. And some of the older stuff, the neutral's all yellow. And the newer stuff, a lot of them have a yellow stripe. But now there's one other thing. You know, we talk about touching something. You don't have to touch anything to get electrocuted. You know, say for instance you're at that car accident, wires on the ground. You know, unfortunately, it's not like in the movies. That conductor isn't always sitting there jumping around and arcing and sparking. It can be sitting there just pumping power and load into the ground. That's what these pieces here are on the ground. That's this superheated sand turned to glass. But say for instance, you know, if you got that line that hits the ground, car accident, where that line's touching the ground, that's the highest point of, you know, voltage. Now everybody's taken a rock, dropped it in a puddle of water. You know, you have all the little ripples. Well, it's the same thing. You know, if you're walking toward a car accident, there's a line on the ground, you're walking across ripples. And the closer you get, the higher the voltage. So if you make one step, your foot might be at 1,000 volts. You take another step, you might be 4,000 volts. That puts 3,000 volts going through your body. So you can get electrocuted without even touching any conductor. So you just got to be real careful, because you're all out there in the public. You know, if someone's going to come up on an accident, it'd probably be you, because you're moving around quite a bit. So that's kind of one of the other little items to think about. But we'd be more than happy to answer any questions you have.
This training today, we just wanted to make sure that you understand the dangers that power can bring. And we want to make sure you understand that complacency is a huge problem in our industry. You start out being taught exactly how to do everything, and over time you end up taking shortcuts, and eventually one of those shortcuts can bite you, and that's what we want to avoid.
I hope all of you fully understand now the importance of using your FVD every day, at every job, to make sure your work area is safe. Power makes all of our lives better, but we need to respect the danger it possesses. Charter has provided you with step-by-step training and the safety tools to get every job done. But remember, your FVD will only protect you if you use it. Our goal is still the same: get you home safe to your family every day. Thanks for taking time to be a part of this life-saving training.